Hello everyone, this is Chris Brooks from Rivsticks Game Studio, and today we want to talk about notifications and debugging. Fun times for anyone not a developer. So as you can see here, we have Clarence. Clarence is a pretty basic monster. He receives his available actions. He randomly picks one, and that's the action he's going to take. So let's go see how that works out for Clarence. Alright, so as you can see here, we have Clarence and we have Rex. So let's go ahead and run this. Clarence is the cat, Rex is the dino. So Clarence doing nothing but turning around when he should be fighting or whatnot. And the dino is going to make, Rex is going to make quick work of him. But that's not really the point of the video. The point of the video in this case is notifications. Yeah, pretty quick work. So now let's say we want to tell the system what is happening in our application. So we want to be able to tell back to the users that something has went wrong, or we want to give some sort of a messaging back, and that's where notifications come into play. So let's stop this right now and let's go back to here. Now notifications are very simple. Any action can take a notification before it is sent back. So let's go ahead and we'll just take this section right here, which is what happens when there's an error condition, and let's just do some updating here. Okay, so every action has a property called notification, which takes this notification object. So we'll go ahead and utilize that. We'll go with player name. Let's give it a message. Well, our message is going to be what action we've taken. So say player name has taken an action to let's just take the name of the action. So player has taken the action of name, and then let's give it a postfix here. So let's give it an ED. Now not all of them will have an ED. It'll sound weird, but we'll go ahead and just do that. So there we go. We've got player name has taken this action. Then we give it a color of our notification. So say we want it to be green. We'll say okay. It's a range between 0 and 1. For I know it's 0 and 256 under most colors, but under here it's 0 to 1 is the range. But this is R, this is G, so let's make it green actually. This is B, and then this is the alpha, how visible it is. So let's go ahead and let's just do it for, let it display for 2 seconds. So as you see here, you've got your message, you've got a color, and you've got how long it lasts in milliseconds, which is 1,000 would be a second. So, alright, so now that we have that, let's go ahead and build. We need to go back here and exit out of here because I'm going to be copying over the DLL. And we're just going to copy over the DLL from the where it was built to the new location, to the CC Players folder, which is my folder for players. And then we'll go ahead and restart Catacomb Crashers. Okay, so we've got Catacomb Crashers. We'll go ahead with same thing, Star Strike. We'll go ahead with only having Rex and Clarence. And we will, oh, we got load Star Strike, load. There we go. And then we will go ahead and run it now. Now every time Clarence throws snowballed, Clarence attacked, Clarence interacted, Clarence attacked again, Clarence rested. So there you go. You get the point. Notifications can then be shown to the screen to show, hey, we had an error or whatever. So let's simulate an error. Let's go ahead and say, you know what? I don't really care about that notification anymore. Let's go ahead and say, now you can't do something like, classically a division by zero error. You can't say something like int c equals 1 divided by 0. All right? Because the compiler catches that division by constant 0. So let's do this instead. Let's go a equals 5. 5 is a good number. Let's go int b equals 0. And int c equals a divided by b. Okay. That's going to give you an error, a division by 0 error. Now that should fall into this catch, which should fall into this notification block, but let's see what happens. So let's build here. Again, I'm over here copying the DLL over. Okay, DLL has been copied. Let's go ahead and launch Catacomb Crashers. Do it again. Get rid of all these guys. These two remain. Let's load them up. And let's run it. Now Clarence now is going to be attempting to divide by 0 over and over and over again. So he's just going to sit there and rest because that's the default action, and he's telling the user what the error was. So what do you do when you need more extensive debugging than just notifications? Well, we've recently put in this ability for you to debug straight from Catacomb Crashers into a debugging application that will read from Catacomb Crashers and return. So therefore you can now step into your monsters directly. So let's go ahead, and as in the dev mode, when you're in the when you download the dev version of Catacomb Crashers, you'll see that your monsters now have a debug option. So we have Clarence from before, so let's go ahead and debug Clarence. Okay, so let's go ahead and run. Now when a monster is in debug mode, what it's going to do is it's two directories have been added to the players directory, one that's outbound, which is a file that's going out, and one that's inbound, which is monitoring it for it to come in. So it's a standard JSON file that represents everything about that turn for the monster. It represents the map. It shows the map. It shows the monster's stats and what the monster is. It shows the available actions for that monster. It has a straight JSON file. So let's go ahead and open that file and look at it. And as you see over on the in the tool, that's just sitting there waiting for this file to return. So let's go here and let's check out what it is. So we have a map which contains every tile on the map, including what features are on those tiles. And then we have the features. We have the monsters, which are the various monsters on the game, the tiles, and the last action it took, which is right here. Okay, or the last action it wants to take, which is forward in this case. Okay, so looking at that, let's go ahead and go back to the directories. And if you go ahead and copy this to the inbound folder, if you look into the game itself, you'll see that, well, let's see, first off, let's see, Clarence is the Cyclops here, so he's going to move forward. So let's go ahead and move right, and there he goes off and he moves forward. Rex takes his turn, and Clarence goes again. So Clarence now has generated his file right here, and he's going to step off. Okay, so as you see, they create an outbound folder, and in that outbound folder they put their file waiting for this inbound folder to receive a file. So how do we step into that as the debugger? Well, we've created a project that's called CC Debugging. It's right here. It's a very simple project where you can go ahead and step directly into your monsters to be able to debug them. So let's go ahead and first let's see what references you need. For CC Debugger, your references are going to be Monster Brain, which is the basic Monster Brain, the same Monster Brain DLL that is inside of the Catacomb Crashers. You have a Newtonsoft JSON, which is also the same JSON parser that is in Catacomb Crashers that they use under the hood. And then the only real difference is you're going to add a reference to your monsters DLL, which is the same DLL that you've put into the CC, into your players folder for Catacomb Crashers. So it should have your monster in it. Then the only other thing you need to do is you need to go into Project, Properties. And right here under command line arguments, there's going to be two command line arguments. The first is going to be your input directory, which your input directory is the output directory of Catacomb Crashers. So in my case, it's CC Players Outbound. That is the outbound file for Catacomb Crashers. You're going to read that in. And then your outbound directory is the inbound folder for Catacomb Crashers. So that's CC Players Inbound. So it's going to pull a file from this directory. It's going to process that file and post a file to that directory. And that's really the only two changes you need to make there, is make sure you have a reference here and make sure that you've got those two directories explained right, shown right there. So let's go back to worker. The only thing you need in code, and you can get elaborate as you want here, you could stretch this out, you could make it a switch case or whatever if you're testing multiple monsters, but we're only testing Clarence, so we just created an instance of Clarence, and we've created the very same call that Clarence wants to return his actions. As you can see, there's something called a full model that's passed. A full model has everything that JSON file has. So if you go like this, you could see that it has the map, me, which is the monster, available actions, and the chosen actions. So it's pretty much the entire game, the entire state of the game right now. So all we need to do is we need to set a breakpoint, and we're ready to go. So we're going to hit start. Now when we hit start, you're going to see it pull from this file and populate down into here. So let's go ahead and start. So it's starting up the console app. It's ready to go. If I move out here, the console app is running, which says the worker thread started, and it's starting to process that file. So as you see, it's stopped on this breakpoint. So let's go ahead and hit F11 to step into it. There we are. We are now in Clarence. So here's Clarence. And he's not doing much as we saw before, but we're going to step in. And there is, all he's doing is he's getting a random available action. So there he goes. There's the action that he's chosen to take, which happens to be throw rock. So he's going to throw rock into nowhere land. And that's all. So you can make changes here. You can debug. You can see what's going on if you have a problem in your app, in your monster. So then it leaves and it's gone. So let's go ahead and move it out so we can see what it does to the front end. Let's move it over here for now. So you should be able to see it change here, as well as this should move over here and then disappear. And you should see the monster throw a snowball. So let's watch and see what happens. Continue. He threw throw a rock, sorry. And it copied it over, but it happened so fast you really didn't see it occur. You didn't see it really move here very much because it pulled it in directly. And then as you can see here, it's processed a file and it's waiting for you to take the next action. So bringing this back over, as you can see, it's sitting here waiting on the breakpoint. So let's just go in one more time. We're going to hit F11. We're going to go ahead and see what the next action is going to be. It's going to be a forward action, which will put him right on that pressure plate. So let's see what happens there. So we're going to run it. We should see, I'm going to move it out here again just so you can see it move on the outbound folder. And he should move forward if you look at this screen. There he goes. He moved forward, and it shows it's in the outbound folder, but it's really not. It just hasn't refreshed the browser yet. Okay, so I'm going to go ahead and cancel the debugger now and just let it, I'm going to close that breakpoint. And let's just let it go. Let's make sure, and you can see the files go in and out. So here we go. We're going to continue. Okay, so you see it's well, he's done, so let's restart. Oh, let's get over here. Let's restart that, and so we could see some more files transfer. Okay, so Clarence is the angler. There you go. You can see the files transfer. You see them passing through. There it is. They pass through again. It's just random. There he goes, right in the line of fire. But anyway, as you can see, that's as easy as it is to debug. You have full debug potential, just like you do with Visual Studio in general. The monsters move around, they'll take their actions, and everything appears right. So that's pretty much it, and thank you very much.